Hey guys, we're going to be looking at section 3 and 4 today to finish up chapter 6. So we need to talk about chemical reactions in section 3 and that they all require a certain amount of activation energy in order to get things going. So if you can think of a boulder that's going to sit there and do nothing until there's an outside force acting on it. And we know what an endo and exothermic reaction is, but an endothermic and an exothermic reaction both need some kind of activation energy in order for it to get started. It doesn't matter if it's an endo or an exothermic reaction. So, actually going back, I'm going to show you a very brief video clip, about less than a minute.
Chemical reactions involve energy being given off or being absorbed. While energy is neither created or destroyed, it does change form or position. An exothermic reaction releases energy. Heat is given off in an exothermic reaction, as in this burning piece of paper. The chemicals used to create explosions in this marble quarry also produce chemical reactions. In contrast to exothermic reactions are endothermic reactions. An endothermic reaction absorbs energy, which results in an overall lowering of temperature. This antacid, when dropped in water, creates an endothermic reaction and causes a lowering in temperature.
There you go. Very quick. Okay, so different rates of reaction. There's different things that can affect the rate of reaction. A surface area, increasing the surface area can increase the rate of reaction. So you can think sawdust versus a whole log. The sawdust is going to go up very quick if you put a match to it versus the log, which will burn more slowly. Temperature increases the reaction rate as well. And think about taking milk and putting it out on the counter or putting it in the fridge. We put it in the fridge because we need to keep the temperature down so those reactions aren't happening as quickly. Concentration, that can be something as simple as putting diluted hydrochloric acid on your hand versus full strength hydrochloric acid. There's more reactants in concentrated items and therefore more reactions going on. A catalyst increases the rate of reaction by lowering the activation energy needed. So when we have a catalyst, usually it goes unharmed as well, and it just doesn't take as much to get things going. And then we have what we call an inhibitor, and this was what decreases the rate of reaction. So we put certain preservatives in foods as inhibitors to help decrease the rate of reaction, and hopefully then foods won't spoil as quickly. So the cells in your body, as living things, they contain biological catalysts called enzymes. You remember that from last year. And after reaction, the enzyme molecule is unchanged. So you can have a reaction occurring, and then afterwards that enzyme isn't destroyed because of it. I'm going to show you another quick video. Oops, not that one, obviously. We just listened to that one. How about this one?
Different chemical reactions have different reaction rates. The reaction rate is the speed with which reactants turn into products. Temperature is one factor that affects reaction rate. Generally speaking, an increase in temperature increases the reaction rate. Take, for example, these glow-in-the-dark sticks. The stick in the cold water does not glow as brightly as the one in the hot water, because the hot water accelerates the reaction rate between the substances inside. Surface area also affects the reaction rate. Surface area refers to the amount of the material that comes in contact with other reactants. For example, this piece of chalk has less surface area than the same amount of chalk powder. A piece of chalk with less surface area reacts at a slower rate than the chalk powder, which has a greater surface area. Concentration can also influence reaction rate. Concentration is the amount of a substance in a given unit of volume. By increasing the amount of reactants, the reaction rate tends to increase. For example, by adding more oxygen to this fire, the fire burns faster. Sometimes other chemicals called catalysts aid in accelerating reaction rates and are common in most living things. A catalyst is a substance that increases the reaction rate, but is not changed by the reaction. Most animals contain catalysts called enzymes that accelerate important chemical reactions, such as in the digestion of food.
Okay, so section 4 is on fire and fire safety. So we know this, you've probably heard of it before, fire triangle. You need oxygen, fuel, and heat in order for fire to occur. And think of this is a little portable barbecue here, but you do have an air vent here for the oxygen to circulate through. You have heat and you have the fuel. If any part of this goes missing, then the fire won't happen. In fact, that's one way that we're able to control fire, is by removing one of the items from the heat or from the fire triangle. And you should know, for fire safety purposes, where smoke detectors, fire extinguishers, and where they're located out in your house, and the furnace and water heaters. Also baking soda they mention here, because with grease fires you should never put water on it. You should put baking soda on it to help suffocate the fire. So now go to the Google form here to answer the questions. Remember, you have to use your pleasantonusd.net account in order to access the form. Thanks.